All right. Hey, everyone. This is my third topic. Well, technically second, but it's actually a big jump. I just wanted to talk about why basically the universe is extremely fascinating to me, and there's three major things that I have learned over a few years that really like made me want to dive deeper into it, and I'm gonna try to put it in the most simple terms for someone who has never heard of them or learned about them. Um, it's it's very the main reasons they're so interesting is because they genuinely stem from all forms of what we believe is regular physics. So, in movies or TV shows, sci-fi genres, there's stuff like time travel, where time basically is distorting itself and bending, and that's obviously not a real thing, but there are certain aspects of this that are real things in the universe that we can't necessarily explain. And I just find that so fascinating about the universe. So the first thing goes along with that. It's called special relativity. It was proposed. I have notes on the side that I've taken before this video. It was proposed in 1905. It's the main idea behind E equals mc squared by Albert Einstein. So to begin, everything on the electromagnetic spectrum, every wavelength of light has a energy level, and it comes from frequency. It has an energy level and a wavelength. So all the speed of these waves are all the same. They're all the speed of light. Speed of light is 3 times 10 to the 8th meters per second. Because you have wavelength times frequency. So wavelength can be high, that means frequency is low. So energy is low. So this is like radio waves, microwaves, and then you have high energy waves, which is like gamma rays, X-rays, etc. So anything relative, which in that term means you're in two cars, right? One car is driving 7 meters per second, one's driving 4 meters per second. The relative to that 4 meters per second car is that the faster car is driving 3 meters per second, right? Because you have a car going fast and a car going the same direction but slower. So the car going faster is slowly passing that car, right? It's passing that car at 3 meters per second. So its relative velocity is 3 meters per second. But at high speeds, which is the speed of light, this is completely abolished. Everything, the speed of light relative to everything, whether you're moving at 100 meters per second or 100,000 meters per second or nothing, you're not even moving, the speed of light is the same. It's 3 times 10 to the 8th meters per second, which is pretty unbelievable to think about because speed is distance over time. So if the speed is constant, it's never changing, and the distance is changing, time changes and it dilates. So something going extremely fast, you will actually notice the clock will slow down and time dilates, which is pretty confusing to think about because it almost sounds like something that could promote time travel, which we haven't gotten to yet, but I just find extremely interesting. And the main reason that nothing can exceed the speed of light is that once you get to the speeds that fast, the inertia is approaching infinity. So that's just like the mass. It's like basically like its inertia is a measurement of like how hard it is to move something. So when that is infinity, you need an infinite amount of energy to speed it up, which is impossible. So basically you can't go any faster than the speed of light, and that's what makes this theory. And it's been around for a while. It's very useful in like a lot of nuclear energy like experiments and like particle motion, particle acceleration. These big particle accelerators in like Europe are like all about this big theory, and it's just very interesting. And then the next two are actually like more space related. It's not, because this kind of stuff can happen on Earth because all forms of light travel at the speed of light. But the first thing in actual space is my second point, which is dark matter. And it makes up 85% of all matter in the universe, except it's not actually classified as matter. Everything in the universe, so everything that exists, is made up of matter until we discovered dark matter, which isn't made up of atoms. So everything about physics, like your soul is made up of atoms, right? Your personality, like it's all based off of chemical reactions that go in your brain. That's all physical substance. This completely just voids all of that. Everything that you've known about matter is gone, and it's 85% of the universe, which is a significant portion. And basically what it is it acts as glue. It's cosmic glue that holds everything in the universe and all the galaxies together. And it makes it exist the way it does. And it's invisible, which is similar to like black holes. It doesn't emit, absorb, reflect light, so it's completely invisible. And the only way we can even see it is because of its gravitational influence and the way it bends light, which is still theoretical. So this is another thing that we know very little about, but it's still extremely interesting because it's such a big part of our universe, but we can't even comprehend it because it's so much different than matter in existence. It's made up of no atoms, and it's just basically invisible nothingness, but is holding together everything that is somethingness, if that makes sense. And then the last final thing is black holes. And if you're not already confused, then this will also confuse you even more. And I'm sure everyone that's watching this knows the gist of what a black hole is, but it's basically a pocket of infinite density, right? And it's so dense that everything that's in it cannot escape because of the gravitational field, because it's so dense, right? Because density is mass per space, right? So it basically has an infinite mass. So nothing can escape from it, including light, which means it's invisible as well. And the only thing that we can make out of it is, once again, the gravitational influence. So we see stars and light bending around it, and then you just see a black hole of just nothing, right? And it's just invisible. And then we actually know nothing about them because we don't know what's inside of them, because it's not like we can just go expedite into a black hole. If once we're in there, you cannot escape. So for all we know, a black hole could be a completely different dimension, and all laws of physics could be completely just useless in a black hole because of how unfamiliar the properties are of it. It's completely just infinite density, and when you're at infinite density, does gravity even exist? Or does the way motion even works, does that even exist? And it's just so mind-boggling and confusing that it just is very interesting. And yeah, that's about it. Those are the three major things that really compels me about the universe and space and time, because it just makes the world seem like it's so much more than it actually is, and it can be an actual like TV show. And I just think it's really fun to do research on this type of stuff, and I hope you enjoyed watching, and hopefully this convinces you to look more into it. But that's basically it. See you guys.